So let's take a look at tornadoes. So in context of what we talked about earlier in this part, remember that thunderstorm cells go through a cumulus, mature, and dissipating stage. And so in its mature stage, you're going to see the crazy sort of things go on, including the potential for tornadoes. So tornadoes drop down out of cumulonimbus type clouds, that's thunderstorm clouds. They are rapidly rising, they're rotating and rising up into the cloud. They're actually associated with the updraft. We talked about updraft and downdraft earlier in this part. And we also talked about pressure changes. And so actually, if you look at the inside, kind of looking down at the through the tornado, this is a very low low, and right outside the wall of the eye of the tornado, you're looking at a difference in 100 millibars, and that is a very steep change in pressure. So a steep change in pressure, of course, creates wind, and then so we have this swirling wind being kind of sucked up into the cloud. That's a tornado for you. So tornadoes can vary a lot. They vary with regard to size and how long they last. So for instance, a tornado can be just maybe a few feet wide, and it can be up to a half a mile wide. Tornadoes can be very short-lived, or they can last for several hours. So they really kind of have quite the assortment. So here's a couple of tornadoes. I think on the next slide we're going to see something called a wall cloud, and this is a pretty good example. A wall cloud is just kind of like a cylinder of the cloud that drops down, and actually we talked about a mesocyclone. Oops, sorry. Mesocyclone earlier. Okay, so actually that's an indication of you have this kind of the blah, 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 this like rotation within your cloud, and the tornado drops down from there. Now, the only reason that you see a tornado, well, there's a couple reasons. One is actually it can be picking up debris from the ground. Dust, maybe perhaps that's what that is, I'm not sure. The other thing is you can see it because actually water is condensing. So you see basically part of a cloud there. That's a tornado. The speeds can vary a lot. We're going to talk about the way that we rank tornadoes according to the Fujita or enhanced Fujita scale. We categorize them based upon kind of after the fact how fast we think that the winds were blowing. But I don't know all the names of the shapes of the tornado, but does that look like a wedge? Okay, they have different names for kind of different shapes that they form. That is just crazy. This might be a rope. Okay. Yes. Goodness gracious, they kind of get your heart a pound in there. So the first line here actually is a statistic with regard to tornadoes worldwide. Worldwide, actually, we're going to see that North America really has a lot of tornadoes, but the one that actually had the most fatalities was in 1989 in Bangladesh. It's a lot of dead. These others actually have to do with our continent. The deadliest single tornado in the United States was 695 were killed, and actually that was a tornado that ripped through Missouri, Illinois, and Indiana in 1925. Also in 1925, that same probably part of the outbreak, the deadliest tornado outbreak. Now what an outbreak is what it kind of sounds like. You have conditions are ripe to spawn one tornado, and they ultimately spawn multiple tornadoes. So, let's see, what else do we have? Widest tornado, diameter-wise, looking at one that is 2.5 miles wide. That is a crazy tornado. It was actually an F or an EF4. Let's see, highest elevation. Oh, this is, I think, kind of interesting. You know how tornadoes pick up stuff and carry them down the road? Well, the farthest something was carried down the road, that something was a personal check, and it was carried down the road 223 miles. So those are kind of some statistics about tornadoes, tornado extremes. This actually are a pair of photographs that were from, it says 2 tornadoes in Tennessee and Kentucky were part of an outbreak of 1984. that killed 59 people. So one of the things about tornadoes, you've probably read the same thing I have, is that they do some amazingly crazy things. Like, I just, you know, the things the damage that they do is just weird sometimes. This, you know, to me, that almost looks like it looks like kind of when we looked at hurricanes. You know, basically stuff is flattened. Okay, so tornado formation, they're still kind of, I'm trying to understand the science of it, obviously, but a couple of things they do think are players with regard to tornadoes being formed is we have to have a strong updraft, okay, remember updraft, downdraft, and then we also have to have some sort of upper level wind to kind of what we call wind shear to kind of get some rotation going. So along those lines, if we think of basically, this isn't a tornado yet, but this is the beginning of the thing that's going to become ultimately the mesocyclone. So basically you have wind down here at the ground, but you have even stronger wind up there. And it kind of, if you take a pencil and kind of roll it between your two hands, that's what's happening with this chunk of air. So then what happens is you can go ahead and have an updraft, and it basically pokes that up. Okay, and that thing is going to stand upright and ultimately become your mesocyclone. So this might look kind of familiar. This looks like a thunderstorm cell, right? You kind of have the flattening anvil up here, and we have overshooting tops here. But here actually is your updraft, and now you see actually it's a rotating updraft, and here the caption says mesocyclone. So that is thought that maybe one mechanism or kind of how tornadoes ultimately form. Notice that when it comes to thunderstorms, abbreviated TS, out of 100 thunderstorms, only one of them will maybe statistically give a tornado. Hail actually is also associated with thunderstorms. A lot of instability causes hail, and that instability then actually it can lead to tornadoes. So let's see, take a look at this one down here. Kind of see the tornado there. I think if I was to say what the wall cloud was, is I would kind of say this little bit down here. Okay, that's the wall cloud, and you kind of see the dust being kicked up. So this is a little bit of a review. This actually looks like a thunderstorm cell to me. This looks like a TS, thunderstorm cell. We see it flattening up at the tropopause. We have the anvil pointing the direction of motion. The penetrating tops, I call them overshooting tops, penetrating tops. It's the same thing. They're going into the stratosphere. We have an updraft and a downdraft. And actually, looks like there's an updraft here, and I know that this is the downdraft because we have our precipitation here. It mentioned that we can see hail oftentimes associated with in the vicinity of a tornado. It's exactly what's being shown right here, hail, tornado. Kind of being shown here is, it says a wall cloud. The wall cloud's kind of that little stubby thing. And if you are trying to assess a situation for a tornado or not, what they will say is look for rotation in that wall cloud. And if it's just, and it's kind of a subtle thing, but if it's rotating, then that could be an indication of your mesocyclone, and it could be a precursor to the tornado that's going to drop down. I know what I was going to say. One thing I didn't emphasize this semester, but there's another special type of cloud called a mammatus cloud, and they look like these little pouchy things on the underside of the anvil. So